Hello class. So now how do we get the derivation formula? So the last class we talked about simple linear regression analysis using the actual formula of the parameter. So how do we get the derivation formula? From the OLS criterion, if you can remember, from the OLS criterion where we have sum and square the error term, then we have this minus beta naught cap, right? Beta naught cap minus beta 1 cap x, right? Beta 1 cap, then you say square. This is what we call OLS what? OLS criterion. This is OLS criterion. So from this OLS criterion, then we can also get the beta naught from the OLS equation 1, right? From the OLS equation 1. Remember the OLS equation 1 we have summation y is equal to any beta naught cap plus beta 1 summation x. Remember, this is what we call OLS equation 1. This is OLS equation 1, right? So if our aim is just to make beta naught sort of formula, so we can easily get the formula for beta naught here by making the beta naught sort of formula, right? So I can rewrite this to be any beta naught cap is equal to y, right, minus beta 1 summation x, right? Just divide all through by n. Divide all through by n. So by dividing all through by n, we have beta naught cap is equal to what? This over n minus beta 1 x over n. Class, remember that summation y over n is the same thing as what? Yes. Recall that y bar is equal to summation y over n, and x bar, which is mean, is the same thing as summation x over n. Summation x over n. So I can replace this with this. So the derivation method for beta naught is beta naught cap is equal to y bar, right, minus y bar minus beta 1 x bar. Class, if you use this formula and the actual formula given to you, then you are expected to get the same thing. For simple regression analysis, you are expected to get the same thing with this formula. Then what is now the derivation formula for beta 1? For beta 1, right? So substitute this beta naught, right, inside the OLS criterion. We have to substitute the what? The derivation method for beta naught inside the what? OLS what? Criterion. That is substitute, right? Beta naught cap for derivation inside OLS criterion. Inside OLS criterion to get beta 1 cap, right? Substitute the beta naught for derivation method inside OLS criterion. Now, what is this? Now, from OLS criterion, recall that OLS criterion is y minus beta naught cap minus beta 1 cap x, right? Minus beta 1 cap x, then all squared, right? So let's substitute this where we have a beta naught. Then I can say we have this minus y bar cap minus beta 1 x cap, right? You can say this minus beta 1 cap x all squared, class, all squared, right? So let's expand this with this sign. So I can rewrite this to be summation y. This time this we have minus y bar. This time this we have plus 1 cap x minus beta 1 cap x all squared, right? All squared, class. Do you know we can rewrite this? We can rewrite this to be summation of y minus y cap and say y minus y cap, right? Y minus y cap plus beta naught x, sorry, this is x bar, x minus s bar. Class, check this, x minus s bar. That means if you expand this, okay, then this will be minus then. Class, this will be minus. So if you expand this, we'll get this back, right? So beta 1 times x we have minus beta 1, right? Minus beta 1x. Then this time this will have plus beta 1 bar, right? Now also recall that small y is the same thing as y bar minus, sorry, y minus y bar, and small x is the same thing as x minus s bar, right? So we can replace this with that. So we can also say that, summation here is equal to y minus beta naught small x cap, right? Small x cap, right? So now let's now differentiate. Let's differentiate this with respect to what? Beta 1. So differentiate this with respect to beta 1. By doing this, we can say that, you know, we are coming from here, right? So you can say the u over the beta what? The beta 1 cap, right? The u over beta 1 cap. So if we differentiate this, we are getting minus x. Then write what we have inside bracket the way it is. We have this beta 1 cap x multiplied with 2 and minus the power by 1 at f is equal to 0, right? Is equal to 0. Is equal to 0. Is equal to 0, right? At the end of the day, we have minus 2x, small x, summation, right, minus beta 1 cap x is equal to 0, right? Is equal to 0. Then we don't need minus 2 here. Then we divide both. Then we divide both sides by minus 2. Then dividing both sides by minus 2, we have x, this small y, beta 1 cap x is equal to 0, right? So expand this with everything we have. We have summation small xy minus beta 1 cap summation x squared is equal to 0, right? So let's move this to the other side. We have xy is equal to beta 1 cap x squared, right? X squared, right? So our aim is to make beta 1 squared to formula here. Then we divide both sides by what? X, summation x squared. So you can say that the beta 1 here, the beta 1 cap will now be small x over summation what? X squared. And this is the formula for derivation method for beta 1. This is the formula for derivation method for beta 1. And class, I can also rewrite this to be x minus s bar. The small x is x minus s bar over y minus y bar all over we have x minus s bar squared. X minus s bar squared. So is either you use this formula or you use the actual method, you are expected to get the same thing. You are expected to get the same thing. What we call this formula to be the derivation formula or the derivation method. What we call the first one to be what? Actual method. So the derivation method or the derivation formula for beta naught now, the beta naught is y bar minus beta 1 s bar. So either this or the one for the actual what? The actual formula. You are expected to get the same thing. So next class by God grace we will solve the mathematical aspect of this using the formula. We will solve the mathematical aspect using the formula. Then after this we move to a multiple linear regression analysis. How do we generate or derive the formula for the multiple linear regression analysis, or what we call a multivariable regression analysis, for beta naught and beta 1, and at the end of the day we interpret our result. I want to advise us to like and subscribe to this channel for you to have access to the subsequent videos. So the next time by God grace, we will be solving the mathematical aspect of this simple linear regression analysis before we move to the multiple linear regression analysis. So I still remain myself. My name is Bashiru Ibrahim. Thank you.